In this video, we have an alternating series right here, and so I will use the alternating series test to show that this series converges, and then show that the series converges to 2 times e to the negative 1 minus 1. Let a sub n be the expression n over n plus 1 factorial. So we have a sub n plus 1 is n plus 1 over n plus 2 factorial. And then now we need to show that the limit of a sub n is equal to 0. And so the limit of a sub n, which is the limit of the expression n over n plus 1 factorial, but n plus 1 factorial, we can write it as n plus 1 times n minus 1 factorial. And then we can see the factors n here, they will cancel each other out. So what's left is just 1 over n plus 1 times n minus 1 factorial, which we can see that at the bottom will approach infinity as n approaches infinity. So we'll get 0. And so we have shown that the limit of a sub n as n approaches infinity is equal to 0. And then we also need to show that a sub n plus 1 is less than or equal to a sub n for all n. So we need to show this. And so notice that n plus 1 over n plus 2 factorial, we can rewrite the n plus 1 as n plus 2 minus 2 plus 1. 2 minus 2 here is 0. And then we can rewrite this as n plus 2 over n plus 2 factorial. And then the minus 2 plus 1 is minus 1. And then the n plus 2 factorial here, this is the same as n plus 2 factorial times n plus 1 factorial. And so the factors n plus 2 here, they will cancel each other out. And what's left is 1 over n plus 1 factorial. And then minus 1 over n plus 2 factorial. And so we have the expression n plus 1 over n plus 2 factorial is equal to this. But since n starts at 1, so this quantity right here is positive, and therefore this entire expression right here will be less than 1 over n plus 1 factorial. But 1 over n plus 1 factorial is less than or equal to n over n plus 1 factorial, since n is greater than or equal to 1. But this is a sub n, and this is a sub n plus 1. And therefore we have shown that a sub n plus 1 is less than a sub n for all n starting at 1. And so by the alternating series test, we have shown these two conditions are true, and therefore this alternating series right here converges. And then now we need to show that it converges to 2e to the negative 1 minus 1. And so the expression n over n plus 1 factorial, we can rewrite it as n plus 1 minus 1 over n plus 1 factorial. And then this is the same as n plus 1 over n plus 1 factorial, and then minus 1 over n plus 1 factorial. N plus 1 factorial is the same as n plus 1 times n factorial, and then the factors n plus 1 here, they will cancel each other out. So what's left is just 1 over n factorial, and then minus 1 over n plus 1 factorial. So this is our series right here. Now we can rewrite this as the summation with the negative 1 to the n, and then times 1 over n factorial minus 1 over n plus 1 factorial. Here are the first 12 terms negative 1 over 1 factorial, it's just negative 1. And then we get 1 over 2 factorial plus 1 over 2 factorial. And then minus 1 over 3 factorial, and then plus negative 1 over 3 factorial. And then the same thing here, the pattern repeats again, 1 over 4 factorial, 1 over 4 factorial, and then minus 1 over 5 factorial minus 1 over 5 factorial. And so this is negative 1, and then we get 2 right here, 2 over 2 factorial minus 2 over 3 factorial minus 2 over 4 plus 2 over 4 factorial, and so on. And then we can factor out the 2 right here. And so the series becomes is equal to negative 1 plus 2 times this infinite sum right here that starts with the 1 over 2 factorial. Recall that the power series representation for e to the x is 1 plus x squared over 2 factorial, and so on. Let x be negative 1, then we get 1 minus 1 plus 1 over 2 factorial minus 1 over 3 factorial, and so on. 1 minus 1 is 0, and so e to the negative 1 is this infinite sum. We're starting at 1 over 2 factorial, but this sum right here is this. And so this part right here would be e to the negative 1. And then simplify, we get 2e to the negative 1 minus 1, which is approximately negative 0.2642. And so in summary, we have shown that this alternating series right here converges by the alternating series test. And then we have also shown that it converges to 2e to the negative 1 minus 1. And that's the end of the video.